Welcome everyone to this webinar on SOLIDWORKS Inspection. My name is Charn Jivaphaiboonskdi and I'm an applications engineer for GoEngineer. Um, Here I have on the front of this PowerPoint my email address. So if you have any questions that we don't get to today, feel free to email me and I'll be glad to answer any questions that you have on SOLIDWORKS Inspection. And if you have any questions that you'd like to ask today, please use the questions section on the GoToWebinar box and we'll address those at the end of the presentation. So we'll get started. So SOLIDWORKS, inspection, why do we create inspection reports? Well, it's a common quality assurance process and it assures that the products that we're designing and producing are meeting quality and acceptable requirements deemed by any regulating bodies or even just internally for what your companies deem as a good product. And for these types of inspection documents that you're creating, you're doing them both internally for any of your manufacturing components in-house, and you're doing it for anything that's outsourced that you buy from a vendor and things like that. For those of you who work with these documentations, you know that the current process is engineering creates a drawing, and from that drawing, you'll most likely print it out as a PDF or on a normal printer, and you're going to start marking it up for the dimensions that you want to inspect per the print off there. Now, after you create these dimensions or these balloons on the drawing itself, you then need to transfer that information over to some type of document, whether it's Word or Excel, that you're taking and you're manually putting in this information so that someone can go in and measure these requirements that you have and record them for you. The issue with this is that with this methodology is that it's a very manual process. You're printing paper and you're ballooning by hand on several drawings. There could be hundreds, if not thousands, of dimensions that need to be called out and recorded. It's a time-consuming process to create that document, and it's prone to errors because you're going back and forth looking at the print and then making sure that it shows up properly on the reports that you're generating. And all of this is becoming a costly process for the involvement for this. So this is where SOLIDWORKS Inspection comes into play. What SOLIDWORKS Inspection allows you to do is to create these reports, whether they're first article or in-process inspection reports, and allows you to also create the balloon drawings so that you can capture all this information. And what's nice about it is that it uses inspection packages such as standards AS9102 that you might be familiar with, or you can create your own custom format as well within the software. And SOLIDWORKS Inspection also allows you to perform inspection and record measurements within the software as well. Now there are two different levels to the package for SOLIDWORKS Inspection. It's known as SOLIDWORKS Inspection Standard and SOLIDWORKS Inspection Professional. Now with both packages, you get a standalone and an add-in to SOLIDWORKS that you can work off. Now these will give you access to working on the native SOLIDWORKS files as well as PDFs and TIFF files that you might normally have within your documentation system. And all of this is using advanced OCR technology or optical character recognition to recognize the information off of those prints for you. And with this, you can create automatic ballooning to help you create the ballooning process that we were describing earlier, and also with the reporting as well. And once you're done with the reporting, you can create a PDF and an Excel document directly from SOLIDWORKS Inspection, whether you're working with a standalone or the add-in. Now, the differences between the standard level and the professional level is that the professional level allows you to automatically measure inputs within the software itself. So if you're using things like digital calipers or digital gauges that can directly feed in to your computer, you can get inputs into the software just like that. You can also import CMM data and have it filter out. And with these, you get an automatic verification and showing you what's within spec and what's out of spec with these color-coded results. So let's jump into the software. I first want to jump into the standalone portion. So this can be used outside of SOLIDWORKS. You don't have to have SOLIDWORKS natively installed on here. And what you'll do is you'll create a new project. And when you create a new project, you're going to choose a template of your choice. We'll choose inches for this example that we're working on today. And I just need to navigate to a file location where I would have access to a PDF or a TIFF file when working for what I want to work on. So I'm going to locate the file I'm looking for. And we can now see that we have our drawing showing up here in this window. And this drawing actually has multiple pages. So if I were to click on the next page functionality, I can see that I have a second page that shows up right here as well. So the first thing we need to do when starting a project is we need to define the parameters of the project or the information that's going to be driving the documentation that we're creating. So over here to the left under the project properties, we can come in and define the part name, part number, and things like that. Now we could manually type in, but we can also use the optical character recognition within the software. And that's this little camera button that shows up right here. When I click on this, what it does is it allows me to go through and filter through my document and highlight over what I want it to capture. So I'm going to capture this part name, and notice that it puts it up right here in this field for me, and I can verify that it's correct information. Let's go in and do the same thing for the part number. Highlight over. And if at any time it ever captures anything incorrectly, we can manually override this information just by clicking in this field. And it looks like it didn't capture the M properly off of this. And I'll go ahead and do the same thing with the revision as well. So let me highlight over the revision, and we can see that it captures the revision. If we needed to add any material specifications, if we had one called out on the drawing, we can do that as well. If we wanted to assign an f.a.i.r report number or manufacturing process and even supplier code, things like that, that can all be filled out within this document portion right here, the project properties. So go ahead and click OK. And now I want to start capturing my information. Now to capture any type of information, we want to come up here to the Draw tab. From here, we have this extract field. And this extract field is where we're going to tell it what we want to extract. So if you have notes, GD&T, dimensions, welds, surface finish, you can specify those by clicking on it. In fact, we want to capture our notes first. So I'm going to click on note, and let's zoom in a little onto this region right here. And so I can make sure I capture just the notes that I want to capture real quick. So I'll click on notes. I'm going to highlight over this first note right here. Once I highlight it over this first note, what this is going to do is it's going to open up a characteristic box that shows up right over here to the left. And I can pin this or unpin this at any time for this. And here we can make sure that what we've captured shows up correctly. So just like before with the project properties, I can come into this field, and if anything was incorrectly input, I can go in and override that information off of there. When I want to select a new note to add in, I just have to go back here to the drawing portion and highlight over what I want to capture and make sure that all that information is captured properly. Now I'll go ahead and recapture this. So if I needed to recapture it, delete that balloon and characteristic. Let me go in and just highlight over it again. There we go. Now we can see that this captures properly. Now, you'll notice that we've added the balloons here, and down here at the bottom, we have a bill of characteristics. And this is just a history of everything that we've captured, and we can go back in and manually edit each one just by clicking onto each one specifically. Now that I have all of my notes captured, I want to start capturing some dimensions. So I'm going to choose my dimension. I'm going to highlight over this dimension right here. And what you'll notice is that after I've captured the dimension over here on the characteristic region, you'll see that we get an image here that shows up for it, and we get specific information. So it shows the type as the dimension, it's a linear dimension, and it gives us a breakdown for what the value is and our tolerance, and even an upper and lower limit to help minimize the error for us trying to manually put that so that our inspectors can accurately see what they're measuring in between off of that. Just like before, I'll capture more information like so. And then if I want to capture something like this radius that has a 2 times callout, what I'll do is I'll highlight over this radius of a 125. And because I know I have 2 inspection data points I need to collect for that, what I need to do is come over here to the quantity section right here and retype in 2. And if I scroll over to the right, there's this little icon right here that allows me to create an instance for each instance. So I'll go in and click on that. And what you'll notice is down here on the bottom, it actually separated that call out right there for the 6.1 and 6.2 to make sure that I accurately count for that. Now, if I want to add in GD&T, let's go in and do that. Let's capture geometric intolerance. I'm going to highlight over this GD&T callout. And what you'll notice is over here to the left on the characteristic box, you'll see that it captures the image and it says for the value C print for GTOL. Now, when it says this, what you'll need to do is just reference back to the drawing for the callout. But if you want this information to show up properly, what you can do is you can override the information. You can come in and manually tell it what you want. So we have to make sure that we go in and we can see a profile of surface. We can capture this information right from this image that was captured before. Off of that, and then put in there, click no to that message right now. And because we have different datums, we can specify the datums as well. So I'm going to specify an A, B, and then a C as well within there off of that. And you can see now we get a nice looking call out located right here that will show up on our print. We can do the same thing for this other GD&T. Let's go ahead and capture that as well real quick. Just make sure we capture the correct information. So I want to make sure I add in perpendicularity for the value, capture that, and then click there. This one only has a datum at A and B off of there. Now, as we're doing all this, once we're done capturing all the information that we're looking for, we want to then export it out. So we'll click back over here to this Home tab, and over here to the right, we have a Publish section over here. And here is where we can publish to a PDF and then an Excel document. And if you also use NetInspect or Quality Expert, you can export out to those as well. But for this example, we're only going to do a PDF and an Excel. So I'm going to click on PDF and Excel at the same time. I'll call it the balloon drawing, and I'll give it today's date. Click Save. And that's created the balloon drawing for us. But back over here in the inspection project, what we'll see is that we now need to tell it what our template is going to be for our format. Now, for those of you who use AS9102, this is a standard that's built into the software, so you can go in and choose this template and specify where you want to export it to. And we'll go ahead and click on Export. Now let's open up the document itself. Now what's nice about this is that this is an Excel document, so it's fully editable in an Excel. In fact, if you're wondering about the other pages for the AS9102, you have them located on each one of these tabs here for the sheets within the document. And you'll notice that all the information that we've captured has been populated into this. So because we captured the part number and the part name, that shows up here, and all the dimensions that we captured show up here as well. And what's nice about this is because of it's utilizing Excel and Excel's conditional formatting, you can directly put in data points right here to measure at 0.35. And notice that it's color coded off of there. You can even go in here and I'll show you an example of it being within spec. So you can see that it's showing up as green off there for that within the software. And then you can save this out to your documentation process and give this to anyone in your inspection group so that they can go ahead and inspect off of this as well. Now, using this standalone process is a very manual process. You saw that I had to capture each information individually here and input it. So let's take a look at how powerful the add-in portion of the software is. Let me jump right into SOLIDWORKS, and I have that same exact drawing shown right here in SOLIDWORKS, and I want to use the add-in portion. Now the add-in portion is simple to click as an add-in. Once you have it installed on your system, just come to the add-ins tab and click on inspection, or you can go the old-fashioned way. We click on the drop-down and click on add-ins, and you can specify whether or not you wanted to have it load up automatically when you launch SOLIDWORKS or just the one time. Click OK. But we're going to focus now on the inspection tab. Now, when you're ready to create an inspection document for this, you can click on New Project. You can specify a template that you've created, or you can use the predefined templates that are already installed within the software, and then you can click on OK. Now from here, we need to specify the same type of inputs that we saw on the standalone portion. So rather than just highlighting over and capturing the information here on the drawing, what I can do is I can actually access the custom properties that were built into the part level or the drawing level and go in and specify that. So we can see that we want the part number, so we'll double click there and it fills in. We can do the same thing with the part name and the revision as well. And then just like before, if we wanted to, we could manually type in the information here as well. I'm just going in and typing in, overriding that value off of there. Down over here, I can specify the start number, the orientation in which it's going to create, and then I can start specifying my sample properties. So if I wanted to have a lot size of 200 and a level of 2, and I can even specify the AQL level from here as well on there, and it will populate that information for me on the document. Now I'll click on next, and this next field allows me to capture all of the information that I want to have. So I actually want to make sure that I capture reference dimensions as well. So I'll capture reference and basic too, along with this. And then if we had any overridden values, especially those of you who are trying to use this on AutoCAD drawings here in SOLIDWORKS, you want to make sure that you have this overridden value just due to the nature that people have created on some AutoCAD drawings when working within SOLIDWORKS. We'll make sure we have GD&T and whole callouts. And then the last page is we want to specify our tolerance. Now, what you'll need to do is set this up for the first time, and then you can save this out as a template so that you don't have to fill out this information in the future. It's a simple process. You can just come in and start overriding values just like so. See, I can highlight there. And once I'm satisfied with all that information, I'll just click on the green check mark. Now what you'll notice is it's going through the whole document and it's going to start ballooning everything automatically for me. I didn't have to worry about capturing all that information. Over here on the left-hand side, underneath the inspection property manager, we can see that all that information is captured and broken down for us. And if we click on each one of these dimensions that we see, we can see what the characteristic number is, what type of measurement it is, and the tolerance called out as well. And we can even control the inspection method. So if you wanted to have the inspection method, you can go ahead and choose that for that on the model. Now, if at any time you wanted to move the dimensions around and it doesn't move the balloon by itself, what we have to do is just edit the balloons. We can go in and attach the balloon to the characteristic, click OK. And now it's just going through and reworking the process to assign it next to it. So now once I start moving these dimensions around, we can see that it's moving that balloon with us as well. So we can make it less cluttered to show up on the actual drawing for that. And just like before, in the standalone, we have an option up here to export out to a PDF and then export out to Excel as well. And then when we choose Excel, we have all of the same templates here built in that we can activate and save out to. Now, what becomes really powerful with the add-in is the fact that you can generate this information in the add-in and then work on it in the standalone without ever having to recreate all this information. What you would need to do is come up here to the Export to SOLIDWORKS Inspection project. Let's go ahead and click on that. And it's going to specify a project file for us. So we can click on the AddIn tab or save it into a specific folder. I'll just save it into this higher level folder. Click on lower plate inspection, click save. Once I look back into that folder, when I come back over here, what that's done is that's saved out a PDF and an inspection project file type for us. And with that, we can actually use that to open it up within SOLIDWORKS Inspection. So go in to Inspection. I'll come up here to this inspection icon and I'll click on Open Project and just navigate to the folder and click there and click Open. Click No to this because I don't care about the first project that I created. And what it's doing is it's extracting all this information for us and assigning it to the characteristic bill of characteristics located here on the bottom with all that information that we saw on the add-in portion in the inspection property manager for that. And then from here, we can go out and export this. So this is great for quality engineers who don't need to have access to SOLIDWORKS directly. They can just request engineering provide them a inspection project file type, and they can open up it up here in the standalone portion of the software. Now, everything we've shown you so far is what would be in the SOLIDWORKS Inspection Standard package. So let's go ahead and take a look at how to activate and see the options that the professional package gives you. So I'm going to go here to the options button, and I'm going to click on measurements input and CMM data import. This will be grayed out if you don't have the professional level, but if you do have the professional level, you can go and click on the green or the check mark next to this and click OK. And what this does is this opens up a CMM data import section over here to the right. And if I go ahead and minimize that for just a second, down here on the bottom for the table manager, just to the right of the bill of characteristics, we have an input option here that we can control and add in specific values off of there. We can even delete that information off of there as well for that. So if you have digital calipers that you use for measurements and you want to have it feed in, just click on the capture button on there and it would feed in directly into this portion of the software when you would have it open. But for this example, we have several different CMM measurements that were captured off of this. So let's take a look at how to import that. I'm going to re-expand the CMM import option right here. And all I have to do is go in and tell it where my data files are. So I'll go into the add-in portion. I have 3 text files for 3 different samples. Notice that I can capture all 3 at the same time. I don't have to do it one at a time. So if you have multiple samples, feel free to add them in all at once. Just click on open. And what it does is it brings in that data information over here. And then we can link it back over here to the drawing. So let's go ahead and click on this auto sign. And I'm going to assign it by the nominal value and have it do its best for this. Click yes to this. And what it's gone and done, and I'll minimize this, or we can actually focus it over here on the right, is it's assigned a dimension where we've put that information for just the best value off of it for the nominal value. And if I click auto hide there and focus now over here onto the bottom for the table manager and the measurement data input, notice that we can see that the dimensions are highlighting green when they're within spec within the software. Now, I'll be honest, when it comes to this, and we can see something that's fallen out of spec here as well. I'll be honest, when it comes to importing the CMM data, your normal workflow process is you will create this inspection document first and then tell the CMM machine what order to inspect it in so that this information populates correctly. Let me go in and open up a completed file that I have right here to show you the dispersion. So let me just make sure I turn on my add-ins, measurement data input, click OK. And I'll minimize this so we can focus more on just this table manager. And we can see now I have a better spread on my data that's been input here. And I do have some measurements that are within close to the upper or lower limits of my measurements that will show up in yellow to let me know that I might need to consider either redesigning that or reevaluating my tolerances off of there. What you'll also notice too is if I minimize this just slightly smaller, on the on the balloon drawing itself, you'll see that it highlights to show whether or not it's within spec or not. So if I wanted to click on this doc or this dimension right here that was out of spec, I could come in and see where it's actually on the drawing that I'm seeing that information. And then just like before, I can save it out to an Excel document and capture all that information. So let's go ahead, and I already have that saved out. Let me open it up right here. And here you can see I've actually created a custom template to accompany all three samples in here. So because this is an Excel document, I have full functionality to fully customize this even further to suit my needs to have all three samples show up right here on it. So one thing I wanted to show you now is just a new enhancement in 2017 that can become quite beneficial. Um, you saw before how when I used the add-in, it automatically populated the information, but there are times when we only need to create inspection documentation for specific dimensions that we're worried about or want to see where it's coming out of spec. So I can come in here and I can zoom in to this region here on the drawing. And when I create a new inspection project, just choose my template. What I want to do is for the extraction, rather than making it automatic, I'm going to set it to manual and click OK. Once I do that, in order to add in the information here on the drawing in a manual fashion, I just click on the add characteristic and start clicking on all the dimensions that I want to add in. So notice that it's extracting the characteristics off of here and it's capturing that. I'll do the same thing for this upper and lower limit here. And this is a really powerful tool to help us extract data on specific information, especially because we don't need to do 100% inspection beyond the first part that's ever received in for either all of our components or lot specific off of there. So it becomes very powerful when adding that in. So let's jump back into the PowerPoint real quick. And we can see that with SOLIDWORKS Inspection, this is going to allow us to improve our product quality and reliability and help us improve our time to market because we're not spending as much time creating these documents and then inspecting it by hand and evaluating that information. And this will help us to reduce scrap as well. So if there are any questions, I'll go on and stay on for about 15 to 20 minutes. If you have any questions, just feel free to type them in here into the questions section on the webinar. If you don't have any questions right now, but you would like to send me an email later on, let me go ahead and jump back to the front so you can see my contact information real quick. And feel free to send me an email so that I can answer any other questions you might have with SOLIDWORKS Inspection.